Okay, good morning students. We are talking about the carboxylic acid. In the previous class we were taking some preparation reactions of carboxylic acids. Today we have to consider the acidity of some aliphatic acids as well as the aromatic acids. Before going to start the acidity of the carboxylic acids, I want to remind you what do you mean by the acidity of a compound. Acidity of a compound is the easiness of removing a proton from the carboxylic acid. I told you this in the previous classes also, that if you take HCl, HCl can be ionized into H plus and Cl minus. Ionization can take place. So HCl is a strong acid because the easiness of the removal of H plus is so good, so high. Ionization means to how much extent, how much easy you can remove the H plus from a compound. That shows the acidity of the compound. Acidity is a property of the easiness of removal of H plus. H2SO4 is also like that. HNO3 is also like that. Out of that, HCl is a strong acid because the acidity is so high. But if you compare to the organic acids, you can see a variety, large number of organic acids. That is formic acid, acetic acid, propionic acid. Similarly, you can see different acetic acid, chloroacetic acid, dichloroacetic acid, and trichloroacetic acids like that. You can see different carboxylic acid and benzoic acid also. I will show you these acids very clearly. If you see some acids like this, you can see formic acid, acetic acid, and propionic acid. And acidity is calculated. Acetic acid is having the most maximum acidity. Formic acid is the least having the least acidity, and propionic acid having the number 2, second position of acidity among these three compounds. Similarly, if you take a section of compounds here, that is acetic acid, chloroacetic acid, dichloroacetic acid, and trichloroacetic acid. Okay, trichloroacetic acid number 1, acidity number 1, dichloro number 2, monochloro number 3, and acetic acid number 4. I will tell you why, how you calculate these all. And if you take two acids like this is the benzoic acid, and nearby acetic acid is written. Benzoic acid is more acidic than acetic acid because of some reason, and I will tell you, explain the reason. Okay, in the last class, our topic is starting from here, acidity of aliphatic and aromatic acids, and again effect of substituents on acidity. In the last class, I told you carboxylate ion is formed from carboxylic acid. RCOH gives RCO minus and H plus. RCO minus is known as carboxylate ion. Carboxylate ion is written here, which can be stabilized by the resonance because the negative charge can move from, the negative charge can move from this oxygen to this oxygen. Okay, double bond is interchange. So you are getting two structures and you are getting an equivalent structure like this. These are the resonance structures of carboxylate ion. I will show you once again. This is carboxylate ion. This is number 2 and this is the net carboxylate ion. So therefore, this carboxyl ion is stabilized by resonance. So therefore, right hand side reaction is predominant. The removal of H plus is so easy, and carboxylic acids are acidic because right hand side reactions will be there always. So therefore H plus ion can be removed easily. So therefore this compound is acidic. I told you in the last class. So let us come to another picture here. This is also carboxylate ion in which X is written here. X is an electron withdrawing group. What are electron withdrawing groups? Electron withdrawing groups are Cl minus, Br minus, I minus, F minus, are halogens. Otherwise NO2. These are electron withdrawing group. Suppose if electron withdrawing group is present here, just like in our chloroacetic acids. This is having electron withdrawing groups. If an electron withdrawing group is here, naturally you can see the electron negative charge is here actually. Electron withdrawing group means electron cloud can be dispersed and it can be moving towards X by inductive effect, positive inductive effect. So H minus charge will be dispersed and dispersal of the negative charge will be taking place and it will be moving towards the X. That is written here. Electron withdrawing groups results dispersal of negative charge, stabilizes the carboxylate ion and increase the acidity. So that means if in this carboxylate ion it is stabilized, that is this ion will be stabilized, this compound, this ion will be stabilized because of electron withdrawing group. So in such case, if it is stabilized, naturally the right hand side reaction will be taking place and this will be more acidic. As I am written, that increases the acidity of the carboxylic acid. Similarly, if it is a group X which donates electrons, which supplies electron, which releases electron, naturally negative charge cloud, negative cloud, electron clouds will be more here. So that's written here, electron releasing groups results an increase in negative charge and destabilizes this ion, and therefore the parent compound shows a decrease in acidity. So in such cases, if you say if it is a methyl group is electron supplying group, OH group. So in such groups are electron supplying methoxy group, electron supplying group. So electron supplying group will give more electron clouds towards COO. So what happens? This will be stabilized. If it is, it will be destabilized. If it is destabilized, naturally this cannot be taking place. Negative, the back reactions will predominate, and this reaction towards the forward side it is not predominant. So in such cases, this compound will show a decrease in acidity of the compounds. I think it is clear. Now you can see this example. HCOH. H is having no property at all. No electron supplying, not electron pulling. Pushing is not there, pulling is not there. H is neutral. In such cases, it is a weak acid. Weak acid. CS3COH, see, electron giving group, electron donating group. So therefore, it is having least. It is a strong acid. It is a strong acid compared with acetic acid. Because acetic acid, electron supplying group is there. So therefore, this is a weak acid. And what about CS3CS2COH? In this case also, CS3 will give electron to COH group through CH2. CS2 group comes in middle. It comes in middle. So therefore, electron will supply to CH2 and COH. In such cases, it is also having a weak acid compared to acetic acid, because electron supply will be coming from a distant carbon atom. So therefore, this is also a weak acid compared to acetic acid. So let us see the strength of the acids. Strength of the acids means acidity of the acids. Number 1 is this one. Number 2 is this one, and number 3 is this one. I wrongly spelled it at the beginning of the class. This one is number 1, this 2, and this is number 3. And what about these compounds? These compounds is acetic acid, electron supplying group. Definitely it will be having less acidity. Here one Cl is there. Cl is given. Cl is giving electron, Cl is withdrawing electron from this side. So Cl is withdrawing electron from this side, means stronger. This is a strong acid. Here there are two Cls. More electrons will be attracted towards Cl. So therefore this is also a strong acid. This is strong, this is weak, this is strong, and this is stronger, and this is the strongest. In this case you can see 3Cl3, Cl, 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 Cl3CCOH. This shows the maximum strength, that is maximum acidity of the compound. So if you take these three, formic acid, acetic acid, propionic acid. Formic acid is more acidic. Acetic acid compared to acetic acid. But acetic acid and propionic acid is taken. Acetic acid is more acidic than propionic acid. So that is that. And let us come to another example. Benzoic acid, stronger acid, and acetic acid. Benzoic acid COH group is connected to an sp2 carbon. In benzene, all carbon atoms are sp2 hybridized. So therefore it is more negative. Electron pulling is here. It will be going towards the ring. This ring is electron deficient, aromatic ring. This is electron deficient ring. Electrons can be moved towards the aromatic ring. This will be supplying. These electrons will be supplying to here. Okay. So this is more acidic. More acidic means H can be removed easily in this case. But in this case, CH3 supplies electrons to the COH group, but formation of CH3CO is somewhat difficult. So this is less acidic compared to this. There are many more examples in these cases. In the syllabus book, it is given many examples. I will take the different examples one by one. But today's class, I wanted to show you some of the examples. Only aliphatic acids and some of the other acids. Cl3, Cl2, Cl6. That is the chloroacetic acid, dichloroacetic acid, trichloroacetic acids. So I think it is clear now how you can calculate, how you can compare the acidity of aliphatic acids and aromatic acids. Many more examples will be followed, but today I am stopping here due to some program, and I remind you, students, you have to see the classes regularly on YouTube until the regular classes begin. That is the only thing I wanted to remind you. Have a nice day. Thank you.